he wants that. Right. Okay. Let's go down quickly. All right, sure. Go down quickly. Understood. This thing is new. And this thing is a main. This is main. This is main formula. Yeah, and it is new, so we'll just keep that in mind, right? The F is something that you know. That will be the frequency of the light, right? We talk about light here, and he wants to talk about light and radioactivity at the same time. Okay, sure, right. Okay, and the H will be a constant. It's a new constant, so you always know H, right? So just want to say that. And E is the energy. The energy of who? The energy of the light.
What is H exactly? Like
H is the Planck's constant. Whatever that is a constant that it will never change. So what I'm trying to say is, if you know the frequency of light, you know the energy of that light. It's as simple as
6.63 times 10 to the power minus 34.
Correct. That guy. And that guy is always there for you. So the formula is actually very simple. There are only two variables, right? The energy and the frequency. That's it. It's a very simple formula. This formula will become a standard thing to quote every time, starting now, in whatever topic that discusses light. So this is officially the energy of a light, which you never have before. You have the energy of gravity, potential energy, you have energy of chemistry. No, you don't have, I'm sorry. You have spring, potential energy, you have kinetic energy, and now you have the energy of light. This will now be considered standard. Like, how come you don't know kinetic energy? That is just supposed to be done by us, right? How come you don't know heat energy, MC delta T, where you're supposed to know? Now this is the case. The bottom one is just a restructuring of the top guy. That is not another thing. So please observe the H is there, right? The H is there. The E is also there, right? The E is the same as the E above. So would you please switch the position of E and lambda, please? So good. Now this looks very similar to one above, right? Because it is C over lambda is F. Because the frequency of light is the speed of light over its wavelength, right? This is supposed to be covered before this chapter, but if this is considered new, then the new formula is actually F equals to C over lambda, not the guy that you see here. The guy that you see is just the guy above. Lambda is the wavelength of light, right? So you probably shouldn't erase that just now. Yeah, but okay. As long as you write this, then this is what you need to pay attention to. C over lambda is also considered very standard from now on, right? I doubt that they will give it in your data booklet. I do doubt that. This is probably considered very standard. Okay. Right. How to apply this? We'll see later.
Yeah, it's not given.
Yeah, but this is considered something that you should know. EHF also, I don't know whether it will be there or not. It's very standard. Okay, keeping this in mind, let us move on. So I'm gonna ignore. I'm gonna say now that this picture is no longer very valid. The reality is more complicated than this. Then whatever you learn in this chapter will reflect that complicated reality, right? This guy.
What is discrete energy? Wait, sorry, I continue.
Something that you will be learning in this chapter. How do I explain this? Okay, let us imagine for now that the electron, we're talking about the electron, we're talking about discrete energy, we're talking about the discrete energy of the electron, not the proton, not the neutron. So discrete charge electron, and the fact that electron has a very close relationship with photon. Photon means light. So discrete energy of electron and discrete energy of photon or light. Now, what does that mean? Sorry, you took chemistry, right? Sorry, I'm sorry. Did you take chemistry? I'm sorry, I'm forgetting things. Sorry. Do you take chemistry?
Yeah.
All right. So in chemistry, you would have learned the orbitals, right? Suborbitals. The fact that your electrons will have, will have first orbital 1s, then 1s1, 1s2, 2s, 2p. Am I making any sense?
Yeah.
Right.
Yeah.
That is the discrete energy. So one more time, 1s and 2s in chemistry, their energy level is discrete in a way that it is like going up a stairs. It is a very clear cut. One is below and one is above. They don't discuss this a lot in chemistry because they don't care too much. But the fact is that 1s and 2s is not a ramp up. It's not a soft approach from 1s to 2s. It is basically a jump. So I hope when I quote the word jump, the word discrete makes sense, because the staircase is not like a staircase. It's more like a wall. It's like jumping from first floor to second floor, vice versa. That's what it means by being discrete. You cannot just climb up, so to speak. You must jump up or jump down.
Okay.
Am I making a little bit of sense right now?
Yes.
Right. Why am I talking about this? Why is the chapter talking about this? Because that's reality. Reality is the electron don't just go up or go down. He cannot do that. He must jump up or jump down. And this picture does no justice towards that. Because the electron here is described as, my orbit is the same as your orbit, right? In reality, there's a bigger orbit which the electron can and will jump up given the chance. Right. So I won't pretend that I've explained everything. I'll just go down and we'll see how it is used, applied, and understood. Right? I'm gonna ignore this guy. This guy is, not very accurate now, right?
Oh,
Energy
wait, I found out something. Sorry,
yeah.
sorry to interrupt you again, but I found out we don't need the PDF thing because you can just insert a blank page from here.
Okay, wonderful. Notability can do this. This is
just my files app. My files. It's just files.
Your files can do that. Your file. Okay. Yeah. So we don't need UPDF.
Then I can insert from a file. So I can insert also insert from things.
Oh, this is so good. That's what we want. So I
have to insert like a screenshot.
Yeah. Then, and there you go. There it is. Yeah. So we don't care about the UPDF now. We don't care.
Yeah,
right? Good. That's what we need. Good. Excellent. Wonderful. You will like this. Yeah. Here. So energy level is really like the level of a building, like first level, second level, third level. The level will be interchangeable with orbit because energy level is energy orbit. Electron don't just stay there, but electron will orbit So the level is the different orbits or the different levels of the building. That is what it means. That's it. Okay, so whatever fancy word he used, that's what it means What is Aryaf? Okay, Aryaf, is that you, Aryaf? Aryaf, is that you?
Yes, it's me.
Aryaf, I will attend to you at 7:45. Yeah.
Okay.
Appreciate that you're coming. Oh wait, it is 7:45. Wait, how come? Wait, what? Oh, Danny.
Time has flown.
Wait,
5 minutes late.
No, wait. Sorry, Aryaf. I might have made a mistake here. Sorry, yeah. Sorry. Let me communicate with Aryaf for a while. Just a minute. No way. This is not. Okay, sorry, Aryaf. I'm the one that is that whole. Okay, this is my mistake, Aryaf. Your first initial time 8:15 was correct. Okay, and the
Oh.
confusion is that Inesh is supposed to come at 8:30. So 8:15, 8:30. You don't have to worry about the clash too much. I think I was very confused today when I replied to your mom. It was my mistake.
Oh.
My mistake.
Okay. I'll come at 7:15 then.
7, no,
Oh, sorry,
7:15.
8:15.
8:15, right? So half an hour from now, lah, right? And then Inesh will be 45 minutes from that. He knows already. You don't have to tell him.
Okay, thanks.
Teacher.
So Inesh, you're there?
Yeah, if he joins at 8:15, then I will join at 8:30 as well.
8:30. You don't have to worry about the camera for now. This is because Aryaf is probably not supposed to be here today. You know, I just want to meet him because I didn't meet him on Sunday. Okay, so I'll speak to him and then I'll attend to you mostly. Okay.
Okay, sure.
So Aryaf, see you at 8:15 and Inesh as per usual 8:30.
Okay, bye-bye.
Sorry for the confusion. Bye-bye. Okay, sorry about that, Daniel. Right. Okay. So atomic energy level is what they mean is the electron energy level. That there is no two different level. It's always about the electron's energy level, the level of a building. Okay.
Okay.
So far so good. All right. I'm going a bit fast right now because I want to revise. I want to review all the different concepts, the new concepts. Now, moving to the next slide, there is energy level in hydrogen atom. What he means is, again, the electron's energy level in hydrogen atom. That's all he means. So moving to the next slide.
Electron.
Yeah, so when he say electron energy level in hydrogen atom, he never meant the whole atom. He just meant the electrons of the atom. As you know, hydrogen have one electron. So the electron of hydrogen is like having the building level. So look at that. Energy level 1, that's building level 1. For some reason, the building level here is not building up, but it's more like a basement, minus 13.58. This is basement, the most bottom of the basement. Basement 1, energy level minus 13.6. I'm not going to explain the minus for now. Just follow me, the fact that this is like a basement. Now, energy level 2 is the next level basement, not downward, but upward. So it's only minus 3.3. Energy level 3, basement above that, which is minus 1, and so far, so forth. All right. So this energy level 1, 2, 3, 4, 5 is the lowest basement until the uppermost basement.
This is uppermost.
Yeah, there is actually 6 and 7, but it's very rarely used. Usually we'll just use 1, 2, 3 because that's the most common interaction that's happening anyway. So we don't see 1 as B1. We see 1 like B5, then B4, B3, B2, B1, something like that. But you don't have to memorize that. From the minus sign, it's already obvious who's deeper and who is higher, right? The only thing here is that minus, it seems to be a very weird way of describing this. I agree, until you see the reason, until you see this.
Wait, so this is energy level hydrogen. So
the
this
energy
is like
not the hydrogen.
H2.
No. Like I said, is the energy level of the electron of the hydrogen atom.
So what do the numbers mean? Because it can only have one electron, right?
It's very simple. The electron is usually at the lowest basement. That's your 1s1. No? That's your 1s1. Energy level 2 is the electron upgrading itself, not cloning itself, just jumping above. For some reason, he reaches 2s1 for some reason.
But that's impossible, right?
No, that's very possible in physics. That as in you
so
can do
in a
that
hydrogen atom.
Yeah, the hydrogen atom, the electron can jump up a little bit without being ionized. That is 1s1.
One is up. One is at top, right, or at bottom? I always forget.
Like bottom means the closest to the nucleus, and jumping up means
the position. The position of the one.
Yeah, that's 1s1. That's 1s1. And 1s2 doesn't mean that there are 2 electrons. No, it means that the 1 electron jumps to position 2.
Also 2s1.
Oh, yes, it is 2s1, sorry. Because 1s1, 1s2 will occupy the same energy level, which you don't talk about it. You don't. So this is just 1 electron traveling up. Okay. Let's not get hung up on the 1s1, 1s2, because your teacher will not code it anyway. He will not. Yeah? The point is the electron goes up or down given the chance. This, therefore, is not hydrogen or H2 or H+. It's just the most normal hydrogen, which is
Why
not
does it want
something.
to go up and down?
Because he can, given the chance, absorb energy from light. One method is to absorb energy from light. You basically just shine light on. The second way is you knock an electron with another electron. The electron kind of absorbs the kinetic energy of the knocking guy and goes up. The third way is to whack atom with atom. When you whack atom with atom, well, you're whacking electrons, so back to the case number 2. Meaning this happens normally. This is not like a special case. It happens all the time, so to speak.
Based on the presence of light.
Light will be what they discuss mostly in this chapter, but you can use other electrons to have the same effect. You can. All right. So jumping up and down of the electron, nothing else, just the electron. Okay, we're moving a bit fast. There is a new unit of energy because we're talking about energy, right? 1 eV is a very small joule, but that 1 eV is what is relevant for our scale here. The scale are atoms. He tried to explain the
electron volt. Sorry.
Yes, electron volt given in the data booklet. And electron volt is just joule, is just energy. It's just something relevant. It's something relevant to us right now. We are just going to use that in anything concerning electrons and atoms and protons and neutrons, all those small stuff. The rest, we don't really care. Okay. He's trying to explain the negative value. I will pretend that it doesn't exist for now. I'll just ask you to believe that they are basements. Right? Okay, moving forward. This principal quantum number is the same as your chemistry law, 1, meaning 1s1, 1s2. That's your 1. 2, 2s1, 2s2, 2p1, 2p2, 3 is actually the 3s1. He doesn't care about the distinction between 2s and 2p in physics. He does not care. Right? That's why I say don't get hung up too much. The point is there's 1s, 2s, 3s. As you can tell, 1s is directly below that, closest to the center of the atom. Okay.
So
now,
ground state is n equals 1.
Ground state is 1s1, which is usually where all electrons should be, given no input. Given no input, he'll just be happily there.
Wait, so from this point all the way to this point, like right before it hits the first excited state, this is all ground.
Wrong. Ground is only minus 13.5. There is no in-between level. Meaning to say, here is your discrete energy level. Meaning to say, there are no stairs. There are no stairs, there are no escalator. You jump immediately to the first excited step, or you don't jump at all.
What? Okay. So where does the energy stored? Is energy stored anywhere?
let's say that if you go to the first excited state, so you basically jump, you jump that level, which is around 10.2. Can you see that? That's around 10.2 EV of jump. Make sense? Right? So if you successfully conduct that 10.2 EV jump, you are at that first excited state and you are storing the energy like that by simply being on a higher level, right? So simply by being on a higher level, you are storing potential energy. That's all.
Okay.
Now, what happens if you throw a rock from ground state to first excited state? It's a level of a building or level of basement, right? And the rock just did not reach the level above you. What will happen to the rock?
Falls back down.
Right. And this is exactly what will happen. If you give the rock an input which is not enough, then you will not achieve anything. The rock will go back. Something like that. He keeps saying the word quantize, which is correct. Discrete finite value, which is correct. The meaning is what I told you just now. Either give him the exact level, exact energy needed, or no point giving him at all. If you don't give him 10.19 in this case, actually, 10.1, yeah, 10.19, then might as well don't give him anything because nothing will happen.
What's quantized? Yeah.
Quantized means to be in a very specific quantity, meaning it is not a smooth gradient, meaning levels. They are talking about all the same thing. These are very fancy words, which means something quite simple. They are just levels. There are no levels in between, basically. Right. What's the specific quantity? Well, in this case, 10.19, the jump from first to second, the ground to first. No intermediate levels. It's not no levels. Obviously, there are levels here, but there are no intermediate levels. There are no stairs to help you, so to speak. It is a very annoying building which does not have any stairs at all. So far, among all the slides from just on top until now, we are still talking about the same thing. Okay, the level of energy, the level of the building, the level of the basement. Let's move on. Transition between energy level. I'm jumping from lowest basement to ground state to, the basement above. See, 10.19. It must be exact. Right? He say it cannot be built over time, meaning you cannot throw the rock halfway and then you throw it again when it's halfway. You don't do that. Give him the right amount or just don't expect anything. This 10.19, therefore, where does it come from? Well, for one, it can come from light. The light is just flying, seeing the electron. The light is exactly 10.19, kena absorb, and then the electron will go up. That's one way to go up. It can also come from a flying electron. Right? Still talking about the same thing. Yeah, a very free electron flying around and then knocking the electron of the hydrogen in this case. The electron gives the orbiting electron a boost it needs. Boom, bump up. Yeah, can happen. Can happen. Still talking about the same thing, right? Still talking about the same thing. Right, next slide. HF, okay, we talk about it. Okay, this is, and CF lambda is what you talk about just now. It's FC over lambda. So this is not new. Let's move on, right? Let's move on. There you go, right? Okay, moving on. This is a little bit repetitive, huh?
It's
All right,
100
and there you go.
integers.
There you go. Right. So he's just reorganizing stuff. Why is he doing that? Because the electron jump is clearly 10.19. How we know they do experiments, right? The joule doesn't matter too much, I feel, until you have to use it to find lambda. Then suddenly you need joule. So this lambda equals to hc over E. The E cannot be in EV. You must convert it to joule. I guess that's why they're showing you all this, right? Now, the reason why we want to convert to lambda is because we talk about photon not in terms of energy usually, we talk about photon in terms of lambda. So there you go.
The energy carried by photon is
CHF, right? You know that. Then the electron needs something, this amount.
So this is the amount of energy it needs.
It needs to jump from ground state to the basement above. Right? From 10.19 EV, right? This 10.19 also never changed one. So yeah, you'll see that. You'll see that often. Then the lambda is just working backward from this. Ground to first excited state, right? Okay. So lambda equals to hc. You'll notice that h and c are both constants. So you just use the E on top, and then you get your 120 nanometer. So far, so good.
Yeah.
Okay, you just have to believe that that's what they plug in, right? It's very simple. The formula is very simple. Now I want to talk about the UV. Yeah, there you go. Yeah, from the bottom. Yeah, from the top. Yeah.
Yes.
No. The one that you work out just now. The one that you work out just now. No,
the
one that you work out in the same slide. This thing, that joule. Yeah, that guy. Yeah.
Radiation.
Sorry, you're saying?
Radiation.
Radiation means light lah. If this doesn't connect, please tell me. Radiation doesn't
light.
mean, yeah. This radiation does not mean like the radiation of uranium. That's not what this word means here. This radiation simply means the photon. If this is weird, tell me immediately.
It's a bit weird.
So I'll use two things to try to explain that. We have time, right? We do have time. Yes, we have. So first thing first, in our common language, we say the heat seems to radiate from the very hot stove. The hot stove is radiating its heat towards us. That's reasonably common language. It's not a physics talk. Am I making some sense?
Yeah.
All right. So radiate, we use in a sense that in common language, use in a sense, oh, this guy is less like shining his heat towards us, sending his heat towards us, radiating heat. Right? Doesn't seem to be a photon, but you bear with me, right? So this is still a common sense thingy, not a new physics thingy. Now, in thermal chapter, you learn that there's conduction, convection, and radiation, correct? The three ways of transferring heat: conducting, convecting, and radiating.
Radiation.
Yes,
yeah, that's heat though, that's not light.
I know. And to your surprise now, to your really surprise, the radiating heat is usually in infrared, which means it is light. It is not heat. It is literally light traveling from that guy to you. You absorb the light, you feel heat, or you feel an increase in temperature.
But it's non-visible light.
Yes,
Sorry, sorry.
infrared is non-visible. UV is non-visible. Most lights are non-visible. Our eyes are not that good lah, so to speak. Most photons are invisible to us. We can feel it though. We can feel it.
Mm.
So this radiation, I hope by these two examples, helps rewire your brain to thinking that this is photon. This is light wave flying, so to speak. And this way of using the word radiation will stay in physics. It will stay. It's like that one. Now, obviously, infrared light is totally not UV. So when I say heat transfer, I say with a very care, I say mostly infrared, but all other spectrum exists. All other spectrum exists. So it's not just infrared. UV also radiate, you know, X-ray also radiate. So the radiation is used for the whole spectrum of light.
Is that why like the sun is hot?
The sun is hot mainly because of infrared, because infrared is mainly the heat component. But there is UV. Clearly, the sun is sending UV to us, clearly. The one that makes our skin black is UV. It's clearly there. That's our sunburn. The sunburn is usually the UV, not the IR causing it. Right. So the word radiation has maybe a new, more expanded meaning to you, right? Hopefully it's not conflicting. Now I want to comment on the UV part. When I see 120 nanometer, he doesn't need to tell me that's UV. I know already. The reason is very simple. I'm gonna make some notes for you because I suspect this is important. Yeah, it was important to the local school, right? So the visible light is from 400 to 700 nanometer. Very simple, right? Quite easy to memorize. I want you to memorize that. So the visible light is from 400 nanometer to 700 nanometer. Very easy to memorize. I do want you to memorize. For some reason, teachers don't ask you to memorize nanometer. Now, let me ask you, where is the red color and where is the violet color? Is the red 700 or 400, vice versa?
Red is 400.
No, red is 700.
Oh.
This is where I want to rewire you a little bit, and maybe we have to call it. We'll take a break. So I'm trying to rewire your brain. Listen to me. This messes up your brain when you are trying to do the question. Like if you don't rewire this. So my brain is sufficiently rewired such that I know 700 nanometer means lower energy. If the wavelength is 700, that's lower energy than 400. That's how I memorize it. Like the wavelength of 700 is longer than 400. So the way my brain imagine is that 400 has more wave, so it's like more energetic lah. My brain is just trying to make sense of it all. So 700 must be red because I always remember that red is less dangerous than violet. Why? Because infrared is less dangerous than UV, so to speak lah. So when he say 120 nanometer is UV, yeah, I know that's less than 400 watt, must be UV lah. Right? I'm making a big deal of this because in local school it is a big deal and people get confused. So I'm assuming that it will be a big deal here also. Right? So a little bit of memorization. You're saying? I'm sorry, you're saying?
I will highlight this.
Oh, please do. Consider this one of the rare instances where I ask you to memorize things.
Yeah, but you never really asked me to do that.
If I try to make you understand, I'm hoping that you don't have to memorize though. But this one, almost no logic one. This one is useful to memorize also. So yeah, we memorize. Okay. Now, we stay quite long in this slide. Let's move on for now.
Okay.
So the exciting and quite unstable, right? Quite unstable. I'll focus on that, and then it's a good time to close for this 45 minutes, right? So next slide. Okay. Excited meaning he goes, he jump up lah, okay? He jump up. He is unstable. That's the reality, and he simply fall down. So for all the effort of making him jump up, he will just return to ground state. I guess that's why it's called ground state lah. I guess lah. Okay. So there are two sentences here that requires explanation, right? So when it jumps to lower level, you don't necessarily associate jumping to dropping, like it's more like dropping, right? It's not called jumping, right? So maybe you change it to a word that suits our brain more, where it drops to lower level instead of jump. The exciting is the jump up. We can say jump down, let's just be very clear, it's called drop lah, right? When it drops to a low level, he loses energy. Make sense? The losing of energy will be done in a form of photon, always. That is the only way in the vacuum of existence, the vacuum of space of electron, the only way he can lose energy is to emit photon. So would you please arrow dropping, lose energy, emit photon? I want you to think like that.
Dropping.
Drops, arrow, lose energy, arrow it through emitting photon. That's why he emits a photon. There is a reason for it. How much of energy does he emit? Exactly the difference of the level. So exactly this value lah. So for this 45-minute long discussion, we just basically make it jump up and then make it jump down. We don't need to make it jump down. He will jump down himself. We make it jump up by giving light, exact number, exact value, and then he will jump down by himself, re-emitting the light by himself.
The photon is light.
Photon is light. Yes, photon is the quantization of light. Yes, it is a light. Photon never means anything else. Photon means light, and it doesn't mean visible light. It means all light. In this case, a UV light.
So it was given sufficient energy, then it is removed and the atom has become ionized.
Now, this is what you like in chemistry, look. H become H+. If you give him enough, remember the ground state is minus 13.58, right? Remember? So if you give him 13.58, which is actually a very difficult thing to do, right? But chemistry assumes that it happens. Right? So it happens, hooray. If it happens, you now have H+. That's all it means. That's all it means. Very difficult to do with light, right? You will do it with a chemical process, which is, again, not what physics are interested in doing. Right. Now, I keep quoting chemistry to give you a sense of familiarity, not to make it more complicated. That's all I'm trying to do. Now, I will ask you to take a break first. We'll continue from here, right? And then I'll see you in, I think, 1 hour, right?
Yep.
All right. Bye.
Hello.
Yes, Aryaf. Can you hear me, Aryaf?
Yes, I can.
All right, Aryaf. All right. So to be quick, because we are supposed to meet on Sunday, and I want to have a good update with you what's going on. We haven't been meeting for quite some time, right? Okay. So today I'm not thinking about a very long or serious lesson. I mean, it's not supposed to be a long lesson today anyway, right?
Yeah.
So let me clarify a few things with you. With you quick, yeah. So Sunday is still a good day for you, right?
Yes.
All right. So the missing is just, accident, right? Understood. Secondly, your mom said that there will be that you can make a decision already based on the CCA timing or something like that, lah. Meaning Sunday.
No, the school keeps Was this delaying the result?
Understood.
Yeah,
Understood.
so apparently it's going to be released on 6th February.
All right. Then can I ask you to do this, Arya? Yeah. Unless there is really no concern with math, right? Unless there is no concern with math, can we just try to do next week? We'll just try to do. We'll assume Sunday and Tuesday first. We'll just assume that, and then the moment you need to change, you can just change it to Sunday and Thursday, right?
Okay.
Right. The change is quite easily done, right? Okay. I can't make it on Tuesday. I'll just make it on Thursday. That's it, look. Okay.
So it's Sunday. Wait, so it's Tuesday, Thursday, and Sunday, or
yeah, Sunday, Tuesday, or Sunday, Thursday lah. So those are the two options so far.
yeah.
Right. So in case your school delays it again, maybe they have a good reason, right? So we'll just assume Sunday, Tuesday until you know the real schedule. Can we do that?
Okay.
Okay, good. I like that you're showing me the I'm done with the dates and everything, right? So we have some stability here, right? So I'm glad that you're showing me some question. It's just that the video is very blocky right now. I can't see it very clearly lah. So you're telling me that you are doing estimation lah, correct?
No, it's this one. Can you see this one?
Yeah, I can see the paper. It's just that the connection is just a little bit slow, so it's a bit blocky lah, right? So
no wonder.
yeah, maybe you can make can you zoom in the camera? That might help. Usually I don't want you to zoom in, but maybe it helps. So it's getting slightly better, but still not. It's not very well. Still not doing very well. Right, it's still not very clear. So this is not exactly good, right? It's a bit zoom in, good. Okay, it's a bit zoom in. Yeah. Yeah, this is not working, right? Why is it so? Either your side is raining or my side is raining. Either one.
Is this
okay, so again, not your fault. It's not your fault. So I'll just look at this. You say evaluate 7 times. Oh, it's getting better, right? 7 times 8 or 7 times -8, correct?
Yeah.
This is not estimation. Meaning to say
it's the starting thing, I think.
All right. Now, I would like to have a discussion with you in this 10 minutes because then I know where you are. This is like very foundational, and we will be needing this from now on. Meaning, this is not a separate chapter. After you learn this chapter, the concept here will be applied throughout all the other topics. Okay.
Yeah.
Okay, good. So 7 times 8 is 56. You just write that down first.
Wait.
That's the easy part, right?
I'm taking my pen.
Yes.
So 7 times 8
is 56, right? Okay. Now, Arya, don't adjust your paper. So you notice that when we are writing, we want our paper to be slanted, and that's very normal, right? Okay. Now, don't re-slant that. Don't. Because in the end, you will go and slant that one. So keep it there, keep the paper there, because you want to be comfortable. It's normal for people to write slanted. What you need to do is to adjust the camera. The camera can follow your slant, you see. Can follow. He can follow one. Very simple. That's the wrong way. The other way. Yeah, the other way. Yeah, the other way. A little bit, just a little bit. The other way. No, that's the wrong way. The other way. Yeah. See. Too much.
it's
Yeah.
not
Yeah, nice. So let me confirm that currently you are slanted, right?
Yeah.
Still slanted, but the camera is following you.
Yes.
This is the good thing. The camera should adjust to you, not you adjust to the camera. Make sense, yeah?
Yeah.
Now, since the video is also getting clearer, very good. Why don't you zoom out? Because usually zooming is not good. I cannot see anything. It's too big on one thing. So zoom out a little bit for me. Yeah, nice. Okay, this is my preferred one because I can see half of your paper. Understand?
Yeah.
Okay. Now, I'm going to say something that maybe your teacher also say like part D. Part D is also equal to 56. Please write that down.
Yeah. Oh wait. Oh, that is not okay. Okay. But D is also equal to 50.
56. Now, the other two, B and C, is going to be negative 56, both of them.
Wait, can you hear me from here?
It's quite okay, Arya. Seems okay,
Okay.
right? Now, we can explain this. We can try to understand this. There is one point that you need to do. You need to memorize this. You need to be able to do this quite like a normal thing.
Yeah,
right?
like my dad taught me this one. So it's like for addition, plus, so like plus one is equal to plus one and plus two, and then negative one plus one is equal to 0.
Which just makes sense, right? I hope that makes sense.
Yeah.
But negative one is, negative 2.
Negative 2.
Right.
And then when it's plus
multiplication
times plus 1, it's 1 plus 1. And then
correct.
1 multiplied by minus 1 is minus 1.
Right. Which is what is in action here, correct? We are kind of applying that. So we have to be concerned whether it's a positive plus minus or division and multiplication, right?
Yeah, so like the multiplication, so the minus is stronger than the plus in multiplication.
But what does that mean to you?
Like when it's like plus 1 minus 1, the sign of the answer will be minus, because the minus is stronger than the plus in multiplication.
You're talking about case BC, B and C, correct?
Yeah.
Because there's case D, like the negative sign canceling each other, so to speak.
Yeah. Negative is plus 1.
Right. Okay. Now, your paper is out of the camera. Does it mean that is your normal? Okay. Normal position, normal position, right? Don't make it straight. Make it slanted the way you. Yeah. This is better, right? Right. Okay. Now, division has the same rule as what you have stated. So A and D is the same answer, correct?
So then this one
it's gonna be 6, right? And then B and C has the same answer, which is negative 6. Yeah. Officially, it's called negative 6 to differentiate it from the plus and minus, right? Now, I'm more interested in the sign. We'll call this the sign. Is the sign positive or negative? Understood?
Yeah.
For part 3, I don't care about the number. You work out the number. For example, A, the answer is 90 but negative. I only ask you, is it negative or positive? You work out the number yourself. Understand? Okay, so B is positive or negative?
B is positive.
Very good. You work out the number yourself. C, negative or positive?
Positive.
Good. D? We're moving fast. D?
Yeah, D.
No, you work out the number later. I mean, you work out the number later. We just don't care about the number right now. So D is how?
Negative 0. I mean, it's just 0.
Which is just 0. So write down 0. So there is a third option, positive, negative, or 0, right? So E, you don't work out the number now. Just work out the sign. Positive, negative?
Negative.
Good. Write down equal negative, and then you work out later, right? Now, in this case, your camera is probably better if you shift it down. That means your paper, because if you look at your video, it's like your paper is only occupying some of the video, right? So rather than shifting the paper up, you may want to shift your camera towards you, if that makes sense. Which one's better for you?
Wait 1 second. I asked my brother.
Okay, sure. Something like that. Something like that. Something like that. So this feels like you're using the fullness of your camera. All right, Aryaf?
Yeah.
Better. Then I don't have to keep asking you, hey, move up, Aryaf, move up. Because I can see everything, correct?
Yeah.
Okay, good. Now, let's work out the sign only. You work out the number yourself after tuition, which is, in 2 minutes, we will have to switch already. F, positive, negative?
Negative.
Very good. G?
Negative. Oh, sorry, 0.
No. Very good. Very good. 0. Write down 0. H?
Positive.
Very good. Now, let's talk about part 4, which is slightly new, right? Slightly new. The positive and negative vector, meaning back then, you only recognize positive vector, like you don't think about positive or negative. So I'm going to give you an example in part A. In part A, you usually write the factors as 1, 2, 4, correct?
Yeah.
So do write that down, 1, 2, 4. And then
For negative,
there is also actually -1, -2, and -4. Look.
Oh, yeah.
I'm sorry. Yeah, -2, -1, -2, -4, right? Yeah. Right. So how do you do that? For example, you will times
Like when you
-1
do-
and -4, right?
Yeah, so like when you do -2 times -2, you get 4.
Yes. 4 you times with 1 and -1 you times with -4. So I guess it makes sense that way, I suppose.
Yeah.
Okay. So 1, 3, 5, and then -1, -3, -5. Now you're gonna stop doing 4 because I'm not really sure what your teacher is trying to do because it's so obvious. After a while, it's obvious. So maybe you just check with your teacher later, see whether this is what he wants or not. Okay.
This is from the book. So like she gave us homework. I can show you my notes, the one which teacher prepared.
No, you check it yourself. The reason why, because we are running out of time already. Right?
Yeah.
So in this 15 minutes, I try to understand where you are, and I'm reasonably happy with where you are. Again, because this is foundational, is it important, right?
Yeah.
Okay. Now, any question you want to ask before you hand over to your brother?
Not much.
All right. Can I just see the last page? I'm just curious. What's the last question here? Understood. Okay. This is no longer negative and positive. This is like this almost feel like how come wait? What is this? This is very weird. This almost feels like a different topic. Could you please flip behind? Can you show me the page behind? The page before the last page. This page still talks about positive and negative.
Yeah.
So it's a more complicated one. So I'm not sure what's happening in the last page, but I want you to practice until this page. It's a homework anyway, right?
Yeah. Until
okay. All right. So so normally in Tuesday, what will happen is in this half an hour, there will be Kakak Brian, which is my assistant. You met him already, right? So by right, I should send you another camera or another device to hold so that you and your brother don't have to share. That's what I'm supposed to do.
Yeah.
Right. Right now, you don't have it because I don't know whether you're doing on Tuesday or Thursday. Now, since I said it to you, let's just do on Tuesday. Then I should be sending you so that you don't have to share, right? Okay, now, let me just confirm that you can do this. You can do your tuition in your room. There's no problem with that?
Yeah, I have another room. It's all right.
All right. Okay, good. So for today, we're stopping just because of that. If not, we would have continued.
Yeah, I have a question though.
Yes, please.
You said that you would give a device for the Google Classroom. I mean the Google Jamboard.
A device for the Google Jamboard.
Yeah, like for annotation.
For annotation. Okay. So the first device is the phone holder that you're seeing right now, right? So that's the first device which I need to send you. The second device, well, Google Jamboard you can access from your laptop. Yeah, but then
you can't write with mouse.
Correct. The thing is this. Okay, I guess this is a question. This is a question for you.
Yeah.
Your brother does not like to write in Jamboard. Your brother likes to type. It's really a personal preference, and I do let him do that.
Oh.
Okay. My question to you is, Jamboard, you must understand what Jamboard is used. Jamboard is not strictly speaking used for note taking because it's usually messy.
Yeah.
You don't want a messy note. Now, if you want your note to be in the Jamboard, that means the note has to be tidy, right? So
Yeah.
tidy means two things. Either you write tidily or you type tidily. Either one. Are you saying, Arya, that you prefer writing than typing? Or you prefer both? Also can.
I prefer writing.
If you prefer writing, then it is important for me to give you that device.
Yeah.
Because then you can write. However, there's a however. However, are you saying that you prefer to take your note digitally in Jamboard, or you actually prefer to do it physically on paper? What's your preference?
I would actually write it on paper.
That means you don't need Jamboard to write notes. You don't need to write on Jamboard.
Yeah. For notes, I don't need to write on Jamboard. But for like the questions, right?
For example, this question. Yeah. You don't need to write on Jamboard. I do not want you to write on Jamboard. Do you know why? Because it's your homework. If you do it on Jamboard, then you have to redo it on paper.
Oh no,
Why bother?
when I saw like a long time ago, I looked at my brother's computer and he showed me his Jamboard.
Correct.
So apparently, he was doing like equation on the Jamboard.
Correct. It is possible for him to do that, and I can provide you the device. But again, Arya, for example, this homework, you would rather do it on paper, right? Makes sense, right?
Yeah.
And that's why I have the phone holder for you, because I can follow your working on paper, not on Jamboard.
Okay.
So unless there is a very specific desire, I will honor that desire, the desire to write on Jamboard. But most of the time nowadays, your brother don't write too much on Jamboard. Why? Because I want him to write on paper, or I want him to type either way. For other students, it's the same thing, Arya. I want, for example, somebody else to not write on Jamboard because it will be double work. You don't want to write on Jamboard and then you continue writing on paper. Too much time.
Okay.
Now, let's try this for 1 week, Arya. Once you get used to it, then you will know, then you can tell me, yeah, I still want to write on Jamboard. It's quite easy for me to honor that request. Understand?
Okay.
So I'm not saying no. I'm just saying, just give it a try for a while.
Okay.
All right. Then please hand over to your brother. Right?
Oh, wait. He will log in using his own laptop, right?
I think so. I believe so.
Okay. Bye-bye.
Bye-bye. Okay, Kyoko, I can see you. Yeah. Can you hear us?
Yeah.
All right. Okay, Kyoko, turn on your video as your Jamboard and everything. You know. Oh goodness, I haven't made the duplicate. I'm so sorry. Oh goodness me. Right, sorry. So Kyoko, you're supposed to use a new Jamboard every time, right? That's what we're trying to do. So I haven't made a new one today. Goodness me, right? 31st, right? Okay, done. Right. You should be seeing today's date Jamboard, right?
Okay.
Give updates, okay? You can give updates. That's why we do that. Okay. So Kyoko, how is it? Have you duplicated the Jamboard?
Yeah.
Right. Okay. Kakak Brian, I saw you. Yeah, I saw you. From the
Okay.
right. Right, Kyoko. Right, good. So we have Kyoko. Oh, goodness me. Right. I'm reading it, Kyoko, right? Oh, goodness me. Goodness me. Yeah, Ines, I can see you. Yeah. Can you hear us?
Yep.
Yeah. Hmm. Understood. Understood. Okay, Kyoko, today is only 45 minutes, so we don't have to do too much. Please put in two of your hardest homework question for our formula. We'll try to do it today, see whether you're smooth enough.
Okay.
Okay, right. If you have the exam syllabus, do tell. If not, then just take note of it.
Okay.
Okay, Kakak Brian, I'm sharing Kyoko's one with you. Yeah. Okay, there's a connection. There you go. Right, I've shared your Kyoko's Jamboard today with you. So, Anesh, let's use a new Jamboard today, right? So unless there's a important update, let's get on the differentiation. Come on, we don't have much time.
Am I doing the daily update thingy?
Unless there's a specific one, because you have been doing updates for Monday and Tuesday. I mean, it's good to do, but there probably isn't much update. If there is, do tell. If not, yeah, do type, sorry. If not, we'll go straight to the action, right? Because today only 45 minutes. And I already used some of your time for Aryaf. So
Yeah, okay, sure. I don't really have much updates.
right. So let's go into action for differentiation. Right, question 13. Okay. All right. So 2 questions only, Kyoko, and then try to do it. So Ines, there should be some lecture note. Come on. Okay, quickly.
Oh yeah. Hold on, my brother took the camera. Give me a second. Okay.
By the end of this week, your brother would have had his own camera stand. So no need to share lah, right? No need to share already. All right, Kyoko. So please start doing it. Kakak Brian, please follow Kyoko with typing.
Yeah.
Kyoko, skip first part first. Remember, that's what I teach you, right? First part, not out of formula. Go to second part. First part is some sort of e-math. Understood?
Okay.
Okay. Oh, in fact, the second part is the e-math also, right? So use the first part in second part. You don't have to explain to use it. Hmm. Good, Ainesh. Are you ready, Ainesh?
Yeah.
So the higher derivative is not a problem at all. You just continue derivating lah, Ken.
Okay.
All right. Do adjust your camera to to cancel the slanting. Very nice. Very good. Right. Okay. This example 4 seems very complicated lah, right? Seems very complicated, but let me just see the page after this, just to make sure that we do have to do this lah, right? It's a bit weird that this question comes to you lah. It's very weird, very weird. Now, where is the class actually?
The class is where I show this here.
The class is here. Can I see the pages before this? It feels unnecessary for you to do this. Understood? Yeah. Okay. Yeah. Are you okay with all the pages before?
Yeah, should be.
I mean, it just gets a bit more difficult, but yeah.
Because those things feels more important than example 14 lah. Example 14 is a rare question which I don't think will happen a lot. I don't want to spend our tuition time in example 14 lah. Right? Why don't we take a risk? We'll just let the teacher explain tomorrow. If you don't understand, then we'll talk about it in tuition. And this doesn't seem like a normal thing to happen for you lah. Yeah, it's more normal for higher levels lah, right?
Yeah. Okay. Oh, I'm with GBT. Oh, I do not have it. That's why I was proving it. Beginning of the
So are you there, Ines? Sorry, are you there? You seem to be out. Sorry.
Hello, yeah, I'm here.
Okay, sorry. I thought you were out. Okay. So now increasing function, decreasing function is a very fancy word for something that is very easy to understand. Now, look at your Jamboard. Yeah, you have a Jamboard for today, right?
Yep, I shared it to you already.
All right. So I'm gonna copy your lecture note. Okay, I'm going to go to your Jamboard. Oh, there you go. Right. Okay. So I'm pasting something. So the explanation is very visual. Hopefully you don't hate it too much. Right, the connection is a bit slow, goodness me. Right, okay. So I'm just asking you to do it then. Very, very slow connection, yeah. We won't wait for the Jamboard. Now take your pencil. Take your pencil quickly, finish.
Okay.
Okay, Aditya, your video on, yeah? You're late for 20 minutes, Aditya. Well, okay. Means you have only 25 minutes, yeah? Okay, not sure that's the best thing to do. Okay, so Ines, 3 random point on the first curve. Now the Jamboard is on. Now I can do it. Right? So look at my Jamboard. I'm drawing something to explain increasing and decreasing function. I pay attention to the gradient of the curve, how it changes. Okay, am I making any sense, Ines? Aditya, can you hear us?
Yeah, hi.
Good. All right. So you're working this here. Okay. So Ines, that's the explanation for increasing and decreasing function. No? Do you understand?
No.
All right. Would you please draw the gradient then, please?
So do we need to
Keep
move
your hand
that
busy.
thing?
Keep your hand busy. Your gradient, please, in the curve. Follow like the Jamboard, yeah. There is no. I'm not trying to do that, Ines. I'm not trying to do that. This is what I'm trying to do. I choose 3 points and acknowledge that the gradient is like that. That's what I acknowledge. I acknowledge the gradient, please.
I mean, the shading thing also works. You can see that the gradient gradually increases.
So please draw it, Ines. Please draw it. Take your eraser, erase your shading, and please draw it. Aditya, since you're late for 25 minutes now, is it okay to not give update? Just jump to the question. Aditya, don't get muted. Okay, where communication is not good. Okay.
Yeah, I don't have my book, so could you give me some questions instead?
For PNC, no. For PNC, if I give you PNC, I'll give you from the local JC, which is not good at all. That means the local secondary don't have this.
Okay, then I'll just search it up online.
All right, sure. It's better to use your past year papers, right? Now, my point is, Ainesh, the gradient, please. Focus on the gradient. The gradient is positive. Positive, positive. Do you see that?
Yeah.
The other guy is negative and negative.
Okay.
I'm being very precise here. This is positive, more positive, and even more positive. So positive, 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 positive. The other guy is slightly different. Would you please write that down, the positive sign, because it will prevent you from getting confused in the future. Which one's a positive, positive? Which one's positive, positive, positive? Triple positive, double positive, single positive.
They're all positive, but just
I know, but which one's the triple positive, double positive, single positive?
It goes from triple to double the same.
So would you please write that down? The other one, oh goodness me, my communication to you is very bad, isn't it? First one, second one, third one, fourth one. Analyze them. Then we can move on. Yoko, if you're stuck, write questions, don't stay there. Write questions or put question marks. Do not be stuck for 5 minutes.
Mr. Phillips,
Yes.
after we finish like the whole like chapter already, like all the questions in it.
So PNC is done.
Yeah.
Your problem is not very major lah. So I'm okay lah. I'm okay with your situation right now. If you don't practice more, I'm really quite okay lah.
Okay.
What's the next chapter?
I actually don't know because they haven't uploaded the scheme of work.
So what's happening in school? Is there any update actually?
No, he didn't tell us yet. Like there's gonna be a test on tomorrow, like a quiz.
Shall we prepare for it? I mean, we have 15 minutes.
Yeah, sure.
Okay. All right. Let's do that for now.
I downloaded the whole PDF of the book.
Okay.
So.
Right. Ainesh, this is the only understanding we need for increasing and decreasing function. Let's see how we apply it, right? Let's see how.
The next topic is series. Yeah, we started on it, Pascal's triangle and stuff.
Oh, binomial.
Forgot about that.
Put some question in the Jamboard, right? We'll talk about it. The slide gets slightly. Okay, Ainesh, moving up, example 15. Moving up, example 15, please.
Are you still continuing?
Yeah, okay, got it. Okay, good. Now, this graph is increasing and decreasing. Does it make sense? Visually, does it make sense? I'm going to the next page, yeah, in the Jamboard.
I just cut off from everything you just said. DC
Right.
anything.
Okay, going to the Jamboard.
Oh, you have to be kidding me.
This graph is increasing and decreasing. Does it make sense or not?
Hello.
Can you hear me?
Yep.
The graph
I
is
can hear you now.
increasing and decreasing. Does it make sense? Goodness me, I have to ask 3 times. That's why I just prefer to type. Okay, no, I'm not going to say it. Just type it.
Oh, hell.
Okay, you're just going to type. Okay, okay. I don't want to say much today. It's too much of it's too frustrating. Right? Right? Do reply something in the Jamboard.
Okay, I've changed the network. It should be better now. Okay, you can continue speaking, I guess.
Yeah, I just want to type. Right.
Okay, sure.
Aditya, do you have a new Jamboard?
Yeah, just a sec. I'll put in the questions and share it with you.
Right.
You go for the R and the alpha, right? Because it's like intermediate working, right? Try put more SF and more DP, so that in the next part, the part 4, then the answer will be more accurate.
Okay.
So
Kakak Brian, check your WhatsApp. Aditya, how is it?
oh right. Okay.
Yeah, I shared it with you and I put in the questions too. I'm gonna
All right.
get out my notebook in a sec.
Ainesh, are you back?
Yeah, I've already answered.
All right, then can you answer the question then? Because he wants you to write down the range. I think
But
you
they
can
haven't
do that.
given me any numbers.
Your words are very unclear. Okay, I'm just gonna answer it for you.
Yeah.
I keep shouting, right? If you understand, move on, yeah, yes. You go move to the next page, okay? Move to the next page. Don't erase stuff. Never erase stuff. Don't save space. Don't save the earth. Just duplicate and move on to the next stuff. Something like that. Don't erase stuff. Don't erase your workplace. It's very bad to do that. It is bad to erase your work. Please don't do that. Please undo.
She really duplicate card,
Okay, surely. Right. Thank you.
the page 3.
Right. Got it. Sorry.
Kyoko, then for the R, right? Sorry, it shouldn't be in decimal. Usually for R formula, the R you just leave it in cert. So you just simplify the cert instead of decimal form.
Next landscape, please. Could you please copy my answer? Do I have to ask you to do? If I don't understand, could you please? Could you please move on, Ainesh? Could you please move on or say something, please? Okay, zoom in a little bit, please. Just a little bit. Thank you. Ainesh, I've replied using Jamboard. Yeah, please do so. Ainesh, can we
think-
start?
Okay, for the part 4, right? So you have 7, 7, 7 plus 7 square root 10. 7 minus 15.435 degree. Okay, so they want the maximum value. So wait, can I get breakout room with Kyoko? I need to explain the graph. A bit difficult for just to write.
Okay. Aditya, landscape, please. Ainesh, press calculator first, just to confirm. Press calculator first. I appreciate the manual work, but the calculator helps you to see whether it's nice or not nice.
Me?
No, Ainesh.
Oh, sorry.
Can you do that, Aditya? That is not easy if you don't know how.
I know.
All
I'm
right.
just like trying to. Oh yeah. Sorry, I got kind of messed myself up on that one.
Which question are you doing?
2A.
2a is not x plus 4. What? That's 2. That's 3a. That's 3a. It's fine if you want to do 3a, but it's slightly more difficult than slightly more advanced.
We did question 2, like most of it in class. Like we didn't do 2A because our teacher said it was too simple. But we
Okay.
did like C, D, E, F, G, and the rest.
Right. Understand? Oh, your differentiation is wrong, Ainesh. How to find your mistake?
I already found it.
Use dot. Good. You did dot and you did find your mistake. Continue. Good. Wonderful. Finally, we got something.
Is this the answer?
We see for a while. No, that's not the answer. Not yet. Not yet. At x equals to 1, the dy dx is 0. Okay, Aryan? Ainesh, sorry.
Where did you get that from?
There.
Oh, you can hear me now? Is it clear?
This is dy dx, right? This is dy dx equals to 0, right? That's not y squared, by the way. You're wrong. This is wrong. This is dy dx. Right? You differentiated, dy dx equals to 0 at x equals to 1 and x equals to 2. Correct? Make sense?
What prime?
Does that make sense? That's not y. That's y prime, which is dy dx. Makes sense or not? Make sense or not?
Yeah.
Oh, I repeat.
Yeah. Wrong.
Would you please test using your calculator? There is negative, positive, negative, positive. You will see this table a lot. Aditya, any problem?
Just checking.
I'm okay with your B actually. Yeah, your Pascal is fine.
Yeah, that's correct. I mean, it's not that hard. I just remember it like,
Right.
yeah.
Try
I
doing
don't
K
know.
and L, please. Try doing K and L. That's the hard thing that you need to do, right?
Yeah.
So Ainesh, what is the answer then? The answer is not what you said. The answer is
Minus.
oh,
No, minus.
the answer is this and that.
Hello.
Yeah, your audio is very bad, Ainesh. Let's not communicate using audio, right?
Is
Just
it-
say you don't understand using the Jamboard. Yeah, now it is, then later it's not. If you
Okay.
don't understand, just type something.
All right. I was actually talking the whole time. I'm surprised you couldn't hear me at all.
I can't. And let's stop doing that for today. Let's stop doing it.
Okay. Okay.
Aditya, K and L, please. Can you do it?
Yeah, pretty sure I can. This would just be like x squared times 2 over x would be, this would be sorry. This would be -2, right? X to the power -2.
I need to see you do it. Let's you do it.
Okay.
Who is minus? Ainesh, who do you want to ask? Who is minus?
Mr. Phillips,
Yes, Aditya.
2 over x means x to the power -2, right?
Yep.
No, it
2
doesn't.
over
It
x.
doesn't.
No. X power -1. X power -1.
X power -1 is 2 over x. Oh yeah.
Ainesh, can you confirm okay or not first so far? Ainesh, move to the next page. Aditya, move up, please.
Oh, yes.
Guys, we will have to stop, yeah? I will have to be with your senior already, yeah? Sorry, yeah, Aditya, you're late. So, next, right? I'll see you tomorrow, right? I'll see you tomorrow. I'll see you tomorrow, Ainesh, and Aditya, I'll see you on Tuesday, right? Moving on,
Yep.
please. Thank you. Right, sorry for that, Daniel and Kiko, right? Okay. Today is a little bit messy. Today is a bit messy. Right? Sorry about that. Right. So Keiko, I'll just follow your Jamboard, yeah? And Daniel, share your screen, yeah? So Keiko, are we still doing the DE lah, the differential equation today?
My D is okay. I
Your
finished the tutorial actually.
Understood. Shall we refresh ourselves with complex then?
Yeah, sure.
All right. So it's gonna be a very refresher. No need to jump too high. Just put in some questions and then we'll do it. Okay.
Oh, I don't
Oh,
have the lecture notes for that yet though.
You don't have the tutorial for that.
Yeah,
Huh.
complex. We really just started on DE.
Right, understood. Right. Daniel, could you make a new Jamboard for me? I think I'll be needing it.
Okay, sure.
Right. You haven't made a new one, right? I don't need to. Okay. So Keiko, what should we do? Yeah. The best thing is to do complex. That is the best thing.
Actually, I was thinking of discussing chem.
Okay. Any
Yeah.
topic that you want. Any topic that you want.
I do have a question actually from homework.
Yep.
But
Put it.
I feel like this is
Got it.
related to the main reason why I'm not doing well in chem also.
All right. All right. Yes. Please do. Okay, I got your Jamboard. All right. Okay, let's go back to the lecture note. Right. Probably be needing it later. Right. Go to the lecture note. Okay? Right. So moving down. We stop at ionization just now, right? Right. So just a minute, Keiko. I'm reading first. Yeah. If you have a question, just
wait.
Oh, it's gone. It's gone. Whoa.
I'm supposed to duplicate the page.
Oh yeah. No, this is good. Daniel, just a warm up lah. Just a warm up. Try to do part B. Look. Try to do part B. I mean, it's not. Yeah, it's not difficult. Try to do part. So meaning you close the working lah, and then you try to do it. Oh, it's gone again.
Yeah.
If you have put it in, Keiko, tell me in case I missed it.
Yeah,
oh
yeah,
yeah, I did miss it. Yeah, I did miss it. Okay. So I'm gonna make it slightly bigger. Make are you okay, Daniel? Just following you, not seeing anything.
Yeah, just give me a sec.
Sure. Okay, done. Okay, Pacific, sure. Okay, yeah, sure. Okay, sure. Right, sure. Good. All right. Okay, good. All right. So, Keiko, your question is the first one, second one, or what?
Second one.
All right. So, okay.
I really
Sorry.
feel like I have a reading problem
man.
for chem calculations,
Right.
especially like the more complex type.
It feels like you're off, yeah? Right. Feels
Yeah,
like you're
maybe.
off. Right. I'm gonna type something, yeah. Give me some time. I'm gonna type something. Daniel, are you okay? Sorry.
Yeah, okay, I'm back.
Okay, sure. I'm just following your work. I'm just following your work, which is the B part. Simple work.
One ground state. Use a much lower energy. All right. Good. Yeah.
Oh, right. Sorry. Are you okay? Sorry, I see a question. I see a question just now. What is it? Why?
No, I'm thinking to myself.
Right. That's fine. Sure. Thinking is good. Because I'm still thinking. I'm still trying to figure out what the question means.
Okay.
If I may clarify, Daniel, we are comparing hydrogen with helium plus, right? The question say helium plus. So in this case, both hydrogen and helium plus both have one electron. So far, so good.
So the difference is protons.
So hydrogen only has one proton, while helium has two protons. So the two proton does matter, not the electron. Good.
Wait, what do you say? More energy is required to overcome the what? The electrostatic force.
Yeah. It's enough. Don't say bond. It's a chemistry word. Don't say just electrostatic force is fine. Bond has a slightly different meaning in chemistry, and in physics they don't use the word bond at all to preserve that meaning.
Okay, so more energy is required to overcome the forces.
Yeah, which makes sense Well, I mean, you're saying that it makes sense for it to be minus 54
Because the answer says bring it to infinity, which I don't understand.
Bringing to infinity is ionization. Infinity means bring it far from meaning you're ionizing it. Meaning you need to give it 54, right? Because it's minus 54. You need to give it 54 for it to ionize. Ionize is to bring it to infinity, to allow the electron to escape, basically. Right.
Okay.
That's just what it is. So when you say bring it to infinity, just think ionization may be slightly better, maybe easier that way.
Okay. So it's like
Yeah, Kiko, I'm reading it a few times. I'm not getting it, so I'm reading it very slowly. If you have another question, that would be. Kiko, let me confirm that they never gave you the K constant of the
KSP.
bromic acid. Never, right? KSP never, right?
Oh, this is actually
Oh, they
practical,
did.
so we had to find out ourselves. But the question after this requires
They
us
give us the
to use
pH.
KSP already.
Correct. They give us the pH. Sorry. Yeah. That is
Oh.
one way to do it. There's one way
Oh,
to do
okay,
that.
okay.
Okay. So let me think carefully.
H is a constant, right?
H is constant, yeah. And remember that the energy here is in EV. You may need to change it to joule because EV is not the standard unit. Joule is.
How do you change it to joules?
By remembering that one EV is 1.6 10 power of 19 minus 19 joule. You just look at the slides before. You might need to be familiar with that number, the conversion. That's just above a few slides above. Yeah, the conversion is fine. Yeah. Keiko, let me confirm that they never explain what the solid mixture is, right? Am I missing anything here?
No.
He just
No.
say that I give you a K plus, right? Which is like, seems to be some sort of like highly concentrated, but together with a solid mixture, contaminated, something like that.
Yeah.
Yeah, that part I don't get at all. Let me think. Yeah. 5 gram contaminated solid mixture sample containing 95% of K plus ion. Okay, I'm gonna take the silliest, simplest understanding of this. Okay, so there seem to be a lot of things to understand here, right? So I'm assuming, I'm not very sure that is. All right, looking good so far. Are you okay, Daniel? Right, simple calculation, just to be familiar. Just to familiarize. Okay, right. I think the next slide will talk about the next concept already. So if there's any question up to now, better clarify first before we move on. I think the next slide is slightly different. Just make sure everything is okay. Yeah.
I think it's fine. Just need
Right.
to remember all the conversion. 1.6 times 10 to the power of 19 minus 19. And then the visible light range is 400 to 700 Newton meters. Not Newton meters,
Nanometer. And nanometer.
nanometer.
And then the which one is red, which one's violet lah.
700 is ultraviolet and
Mhm.
400 is infrared. Wait. No, 700 is infrared, 400 is ultraviolet.
Yeah, no, not ultraviolet, violet lah. That means
Or violet.
smaller than 400 UV low and then bigger than 700 infrared lah.
Where is it?
Right.
Yeah.
That's why 120 is UV lah. So UV is, smaller than 400.
Mm.
Infrared is bigger than 700. Right. Maybe gonna be useful after this. Maybe. I guess.
Okay. Emission spectra.
Right. So whatever this is gonna be slightly new lah. It's gonna be slightly new, and it is quite easy to understand. Right? Quite easy to understand. Now, helium, neon, argon, krypton, and xenon are pure gases lah. That's what he's trying to say. Inside this tube, the helium is pure. The neon is pure. Okay. Helium, very weirdly, only emit around 7 wavelength, around there, 7 wavelength. 7 very particular wavelength, right? Something like that. I mean, it's more than 7, but the obvious one is 7, right? So let me give you an example. The helium will emit, for example, just now, what's the nanometer just now? I'm just going to pretend that this is what we're going to use. Just a pretend, was it? 2415 hertz, that's the frequency. Oh, they never ask you to find the wavelength. They never ask you to find the wavelength.
It's just for transition from level 4 to level 2.
Okay, so I'll just pretend. It's pretend. Yeah? So only nanometer, and then let's say this is 200 nanometer, and then there is 291 nanometer. Whereas as comparison, the next guy, argon, will emit, for example, 150 nanometer, 234 nanometer, and 305 nanometer. Right. This is for example. So helium emits a very specific set of wavelength, and argon emits a very specific set of wavelength, and nothing else.
Mm.
Right. It is almost like a fingerprint. Emission spectra will be the fingerprint of helium, because helium only does this, argon only does that, hydrogen only does something else. Again, the numbers are very specific. So far, so good.
Okay.
The first number, which is the smallest one, that means the most energetic, will come from the transition from 1s to 2s, 1s to 2s. Usually, this is your 1s to 2s. I'm still talking about, I'm still looking at the Jamboard, but yeah.
Can I ID gases all gases or just some gases?
I'm sorry. Yes, all gases. All gases have its own fingerprint, not just the noble gases, but the noble gases are easy to isolate, so we use them. Plus, they look pretty
Mm.
So we actually use them for neon lights. The neon lights actually contain different combinations. Yeah, Keiko, I was thinking about it. I'm just not sure, you see. But if you have an answer key, you can just check for me. I still cannot wrap my head around the question fully. Not yet. But if I'm correct, then no need to think too much already.
I don't have answer key. This is homework.
Understood.
Practical, actually.
Right. So containing bromic acid with content. Yeah, it's just that I'm not so sure that 0.1215 mole over 100 centimeter cube is the answer, because by right, the K plus would have somehow reacted with the tiny amount of BrO3 minus. I'm guessing that this is not the case, but for the love of me, I cannot figure out how to start figuring that one out. I'm trying to figure out the pH 176. That is already a bit confusing for me. How come when you add OH, your pH is still very high? I'm already very confused, right? So I'm just still thinking about it. Yeah, that's why I never say that that's the answer. I just start from initial.
Okay.
I think that's the case. I'm not sure. Yeah, I'm not sure. It's very confusing for me. Okay. Obviously, if I don't finish, I'll figure it out after the tuition. Right? Okay, so back to you, Daniel. We are doing fingerprinting, and the fingerprinting tells us who is who. So we work backwards, because we know helium fingerprint is this. Then if we see a fingerprint like that, we can work out that, oh, that guy has helium. I'm giving a very practical example, our sun. How do we know that our sun have helium? Nobody can actually collect helium from the sun. No way, man. But we know that our sun is mostly hydrogen and helium because of this fingerprint. When we analyze the light from the sun, we see clearly the fingerprint of hydrogen and helium. So the scientist is not bluffing when he say sun is mostly hydrogen and helium. Okay, I'm giving you a very practical example. That's how the scientists use it for them. Am I okay so far?
Yeah.
Right, now let's move to the next slide, because I believe that is not what they want to talk about. Right? I believe they want to talk about something else. Right, so whatever spectroscope is, I mean, this is the thing, but we wouldn't know how to use it or what it looks like, kind of. But here you go. There, he even used the word fingerprint. So this guy will be the fingerprint of somebody else. Oh, barium. He tells us barium gas. Okay, there you go. That's the barium gas fingerprint, which is very specifically on certain numbers. You can see that it's very, very specific. And the fingerprint of hydrogen will be slightly different than this, no? Something like that.
Yeah, I have a question.
Yes.
So he says heated barium gas. So will cooled barium gas have a different fingerprint?
A very good question. Why barium gas? First thing first, barium is metal. First thing first. So far, so good? Yeah. So to make barium metal into gas, obviously you have to heat it. There is no such thing as a cold barium gas, because barium is by right metal. You have to heat it up. In fact, you heat it up into very high.
Okay. What about
hydrogen?
Hydrogen. Yeah, hydrogen, for example.
Hydrogen is naturally gas. Now, to make hydrogen, the reason why you heat up hydrogen so that it gives off more clearer spectra. If it's a cold hydrogen, it might be difficult to analyze because it is how do I say this? It is too cold. That basically that's what it means. If it is hot, electron keep jumping up and down. Remember, the heat can allow the electron to get excited. Remember, excited and then drop down. You learn that excited, drop down. When he does that a lot of time, he releases the photon. Then the fingerprint is clearer. So heating it up does serve a purpose to make it clearer. Right? Is that your question?
Yeah, basically.
So if you want to know, yeah, heating up just makes it more clear, right? Because you get more photon out of it. If you're okay, then we move on. When you move on, I'll explain more. At least your slide is going slowly. Again, Keiko, just to confirm that there is no other question right now.
I think I have a more general one. Like,
we
tried the reading method for math, right? How can I do that for chem? And bio actually, but yeah, the sciences are both the same.
I would like to discuss that with you on Thursday, since Thursday
Yes.
will be solo and we'll be using a paper. That will be easier to show you, right?
Yeah.
Okay. Yeah, I'll love to answer that. Okay. So
Sure.
Thursday. So for you, Daniel, the Brackett-Paschen-Balmer series is not important to memorize. You don't even have to know they are. I'm guessing here, but you don't have to know who they are. You don't have up too much upward. Okay, I'm gonna ask you to skip that slide. If I'm wrong, we'll find out very soon. Right? Okay.
This feels like chem, bro.
Feels like what? Sorry.
This feels like chem already.
Feels like what? Sorry.
Chem. A bit.
Chem.
Chem.
Does chem uses spectrometer? Yes, but I don't know about your syllabus. I mean, in real life, spectrometer is more of a chemist device right now. Chemist likes to use it instead of that. But I don't know. Maybe not. Maybe not. This is supposed to be more physics than chemistry in your syllabus field, right? Right. If there is something that you want to ask, however, why is this like chem? Then just go lah, but ask specifically. Okay, so light source, whatever. Okay, so we're talking about emission and absorption. We want to talk about that. We want to try to understand that. It's a very easy thing to do if you don't butcher the explanation, right? So please observe that the absorption and the emission spectra is exactly reverse of each other. That is not a coincidence, right? Because we're talking about the same gas. So what he may not explain in this slide, go to Jamboard page 2, is that we are talking about the same gas. But relatively, one is cool relatively, and one is hot relatively. So for hot, you will get your emission spectra. For cool gas, you will get your absorption spectra, and they're actually just reverse of each other. So much so that they are interchangeable. So far, so good. Yeah. So again, we're trying to identify, right? We're trying to identify, I guess. That's our point. Because fingerprint. Look at the Jamboard, sorry. Look at the Jamboard. Next page. Next page. Oh, yeah, it's not there yet. Oh, goodness me.
Oh, oh God.
There you go.
Okay.
So we're trying to identify, right? Because fingerprinting, I don't know what this gas is, right? I don't know what this gas is, right? So we can use the cool gas with light source method. You'll get absorption. You can use the hot gas method. You'll get the emission. Whichever it is, both will give you the same conclusion. Now, when they say hot gas, maybe they refer to the sun. Sun is obviously hot. So you have to do emission for the sun. You cannot use absorption. Maybe you talk about cool gas, which is relatively cool, like chlorine gas. So rather than heating up the chlorine gas in the lab, just use absorption spectrum method, right? The nuances are totally lost in your syllabus. Like why certain things are better than the rest, they don't even bother to ask you. They just say, sometimes absorption, sometimes emission. Please understand that both work. That's the extent to your syllabus. Now I'm going to explain that. Okay, Daniel? Don't go to your note. Don't do it. Go to your Jamboard first. Stay at Jamboard for a while. Let me explain first. Right? So now, hot gas emits only certain wavelength. That's the easiest thing to understand, right? Hot gas like that, no? Done, no? Again, hot gas emission spectrum kind of easy to understand. Can you accept that?
Yeah.
So why do cool gas absorption spectra? Now, very simple. Because without the cool gas, the spectrum will have no ID. The spectrum will be everything, which is because the light source gives you every part of the spectrum. So far, so good?
Yeah. When the absorption
Therefore,
spectrum shows you what's absorbed. Like
yes.
That,
the cool gas absorbed instead of hot gas emitting. Okay, or that sounds like how come it's the reverse? It's very simple. It's very simple. Remember, because gas keeps, if you give the gas an incentive, the electron will jump up, remember? From ground to first, right? That's what the electron will do, right?
Yeah.
So when this particular wavelength goes through the gas, because gas are basically transparent, it goes through the gas, but some part is being absorbed there. This guy is being absorbed. Ding, 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 ding. That guy is being absorbed because that's the proper wavelength, and it gets re-emitted. Because remember, when you go up, you go down, correct? That's the re-emission of photon. Can make a guess the direction of the re-emission. When you absorb, you re-emit. Where do you re-emit? Make a guess.
I'm not sure.
You re-emit randomly,
Random.
not in the same direction as the original direction. The re-emission, that means absorb and re-emit, kind of changes the direction of that particular wavelength. One more time. I can absorb because it's the correct wavelength, right? I can absorb. The cool gas say that I will absorb, then I will automatically re-emit. The re-emit, I will re-emit in anywhere I want, in any direction I want, not the original direction of the light source.
So direction matters.
Because the spectrometer only in one direction. Only here.
Oh.
So the absorption kind of scatters certain wavelength. Therefore, you see the blank line. No, that's it. That's why. Remember, yeah, absorption still means there's re-emission, but not in the same direction. Therefore, absorption they just call it absorption or whatever. Yeah.
Okay.
It is not true that it absorbs and never emit. That's not true. Yeah, just saying that. That's not the physics. And I have finished explaining you absorption and emission spectra. That's it. Again, the nuances are totally lost. I don't explain you the nuances of why.
They probably won't test the nuances.
The nuances they won't test. But just now what I say to you, they sometimes test. They just want to know how do you know why absorption is absorption and emission is emission? Do you know why? Something like that. If you understand, time to take notes. Yeah, around here.
So it emits from all directions.
Yeah, the emission all direction. Therefore, you see the blank. You see the blank. The emission of hot gas also in all direction. Also, you're correct. Also, but we don't care. We just pick up in one particular direction. It's fine, right?
Okay.
Right. If you understand this, then when teachers switch between absorption and emission, you wouldn't be confused because they are the same fingerprint. They are just slightly different mechanics. Okay. Yeah, they will assume that you know they are the same. They assume that you know, so they don't bother to explain themselves why sometimes they give absorption or sometimes they give emission. They will assume that you know they are the same. Right? That's all. Right? Okay, so the next slide is just an example of fingerprints. Right. So moving on to the next slide, if you're okay with this one, right?
Sure.
You don't have to memorize the fingerprint, obviously, but the hydrogen fingerprint is simpler in some ways than the neon fingerprint. You don't need to memorize that. You don't need to, right? That's just them showing you that the fingerprint is very particular and very different. You can see why they are useful, so to speak.
Mm.
Okay, so moving on. Right, one more slide. Let's try one more slide. He go and explain all this. This is just the quantize, which is to say they are very specifically in one quantity, right? Which is what you're seeing here. Those are lines. Lines mean the energy level is quantized. Historically, they discover emission and absorption spectra before they talk about the theory of quantization. Your slide has it the other way around, right? He explained the quantization, then they give you emission absorption spectra. Historically, it's the other way around. People were trying to try to explain how come the spectra is very specific. Then the theory comes out. Oh my goodness, maybe the energy level in atom is quantized. It was a big thing back then. The nuances are totally lost again right now. It's just gone. But maybe to your good news, they're just repeating the same thing. There's nothing new here. Okay. Right, let's see the next slide. I'm trying to find something new here. Next slide, please. And he is totally explaining the same thing. He's just doing that. He's just doing that. Your slide is very repetitive, right? Maybe because it's a summary, right? Oh, it is finished. Yeah. If I'm not mistaken, after that, that's radiation, no? The real radiation, the uranium radiation. So it's good that we stop here. Right? I'll see
Just
you.
nice. Uranium.
Yes.
Wait.
After that is uranium. After that, we talk about a totally different thing already. The serious radiation.
No longer light, or still light, but different kind.
It is still light, but a super dangerous light. Nothing like UV. Even more dangerous than X-ray. I guess that's why radiation can be very harmful. The radioactive radiation is very harmful.
Radioactive.
Right. We'll stop here for today, all right? I'll see you on Sunday.
Okay.
All right. Bye-bye, Daniel. Yeah, so okay. Yeah. So Keiko, I end up not doing much because
I'm fine. I have GP test anyway.
Correct.
I have to study.
Is it okay to discuss the chemistry on Thursday then?
Oh yeah, my GP test is on Thursday, so it'll be done by then. Yeah.
Right. Okay. Yeah, I'll think about it tomorrow, right? This thing.
Sure.
Wait, let me confirm a few things. Let me confirm.
Wait, sorry.
Okay. Let me confirm. I asked about the solid mixture, right? Content.
Oh yeah.
So there is no explanation. The solid is fine. Yeah. Yeah, the part 2, which your question is, does the question mean this, like the concentration of K plus before the addition of NaOH? Let me just confirm that that's what the question is asking.
Actually, I'm not sure.
So I'm assuming that.
I just assumed that they added it already.
because if they added it already, by right, all K plus would have precipitated.
Yeah, that's true.
I'm reading like until potassium bromate is precipitated, right? So I'm assuming that, oh goodness me, it can be the BrO3 which is gone, isn't it? Let me think carefully. No, okay. It can be the K plus gone or the BrO3 minus gone, right? It can be either one. Fair enough. I made the assumption that it is K plus because of the intent of the question. The intent of the question is to separate the potassium cation. You're adding bromate for that purpose. So I'm assuming that K plus will be gone instead of the bromate is gone instead.
Yeah.
There is, however, an assumption. There is an assumption. That is not. Oh, goodness me. Yeah, let me think about it.
Yeah, sure.
All right, sure. I'll see you on
I thought I
Thursday.
was reading the question wrong.
Maybe we are reading the question wrongly, and maybe it is simpler than what we thought. Maybe.
Yeah, it's only 1 mark actually. And it's practical some more.
Yeah, practical shouldn't have too much conceptual problem, right? Right. So maybe we are totally missing something, or maybe my initial assumption on K plus might just be the answer. I really don't know. I'm not sure right now.
Maybe.
All right. So we'll see lah. We'll see. It's homework, right?
Yeah.
I'll see you on Thursday.
Yeah.
Bye bye.
Bye-bye.